All right, good morning everyone. Today we're going to talk about a topic that a lot of you may not be super familiar with. We're very familiar with NFPA 70E, which is how we create an electrically safe working condition. We've all talked about that. We've had classes on that. Today we're going to talk about NFPA 70B, which is all about maintenance of equipment and why that's important. So one of the changes for 2023 was NFPA 70B is now a standard. So it went from should to shall. Now, most of my electricians, we deal with the National Electric Code, so we understand should and shall is all throughout the National Electric Code. Should is, that's a good idea. It's a good practice. Shall means it now has to be done. And that's what happened with NFPA 70B. It became a shall, it became a standard, which means that OSHA can now use it to enforce it. So is it mandatory? OSHA is mandated by federal and state law, and then it's supported by our three main books that we use: NFPA 70, National Electric Code; NFPA 70E, Standard for Safety in the Workplace; and then NFPA 70B now is another one, Maintenance of Equipment. So standards are no longer a suggestion. NFPA 70B shall. So shall means it's a mandatory requirement. Now we need to follow NFPA 70B. It defines the fundamental testing methods and equipment that needs to be tested and at what intervals it needs to be done. So you need to have a written program, written in maintenance program, and you also have to have a person in charge of that program. So here are some of the elements that have to go into this program. It addresses the condition of maintenance of the equipment, identification of the person who is responsible, survey and analysis of all the equipment and the systems to determine their maintenance requirement and priorities. So when we go into a facility, you can't just start off and say, okay, we need to do infrared thermography every 6 months. Well, first thing we need to do is identify the condition that the equipment is in at that moment. That can change the intervals and when things need to be tested and maintained, because we need to know where are we at right now from the beginning. How are we doing right now? Has this equipment been maintained before? Is it new, or is it in pretty rough shape and we need to basically start from the beginning? Develop and document and maintain procedures for the equipment, plan of inspection, servicing, and suitable testing, maintenance equipment and personnel documentation and record retentions policy, and a process to prescribe, implement, document corrective measures based on that data, and incorporating design for maintainability in electrical installations, and a program review and revision process that considers failures and findings for continuous improvement. So obviously you're always trying to get better, trying to make sure that the equipment is being maintained properly, and then moving forward, everything is going to be on track so that it is as safe as possible, but it's also about reliability, functionality, making sure the equipment is doing what it's supposed to do, so that whatever industry you're in, whatever company they are, they can continue to have that equipment working in a functional environment for their product. So NFPA 70B, scope of work, electrical equipment, scope of maintenance, condition of maintenance, environmental factors. Are we in a sawmill where there is all kinds of sawdust everywhere all the time? That may need to be cleaned and maintained on an earlier basis than equipment that's not in an environment like that. Use of equipment outside of its designated rating, level of danger with equipment failure. So some types of maintenance and inspections that we have to do. You have visual inspection, just taking a look at it. What are we looking like? What does the panel look like? What does it look like inside? Cleaning, lubrication, mechanical inspection, servicing, checks, electrical testing, corona detection, maintenance and testing, servicing, special procedures. So why is NFPA 70B important when it comes to safety? That's a very simple one to talk about. Let's say that we look at a arc flash label, and the arc flash label has the incident energy listed. The engineer has put in a calculation to decide on that arc flash label what the incident energy is. A lot of that depends on maintenance. It is clearing times. I always say there are really only two things that help you when it comes to arc flash: distance, further away you are, the safer you are, and time. When is that overcurrent protective device going to open? Arc flash is going to continue to grow as long as there is a source feeding it. It's going to continue to get larger and larger until that overcurrent protective device opens and shuts that power off. So when is the breaker going to trip? Well, if that breaker has never been maintained, it's never been serviced, it's never been exercised, it's never been cleaned, it's never been lubricated, we no longer know that it's going to open at the appropriate time. The time that was listed into the coordination study, the arc flash study, when it was done. So that information on an arc flash label may not even be accurate, and you could put yourself in harm's way thinking that you're protected. Maybe you're wearing an arc flash suit, whatever the proper clothing is for that level of incident energy, and then it doesn't work correctly. The incident energy is no good because the breaker doesn't open on time because of a lack of maintenance. Or a simpler thing I mentioned, working in a sawmill. You open up a piece of equipment and it's just full of sawdust. Sawdust is combustible, can explode. So you're looking at a piece of equipment and you don't see that it's filthy inside. And something happens, triggers an arc flash, and now you have another combustible element that you've added to that danger. Can make a big, big difference. NFPA 70B is going to have a huge effect on electrical safety. It is going to make the industry a lot safer because this equipment is going to have to be maintained. So why it matters: safety, compliance, cost savings, always good for the customer. You know, how am I going to save money? You're going to save money because you're not going to have unscheduled shutdowns. Unscheduled shutdowns are just a big pain. The equipment goes down and now all of a sudden we got to go in and fix it. How much does that cost? Everything is shut down. Nothing's working. Your product, whatever it happens to be, is not getting out. Scheduling that shutdown, now you can work around that system. But when you have unscheduled, that is the worst case scenario. Reliability. Is the equipment going to work? Is it going to work the way that it's supposed to, efficiently? Downtime causes loss of operation and disrupts workflow, costly repairs, employee exposure to hazards. Anytime we do something on an emergency basis, hey, we got to get this done. We got to get this done now. The rate of injuries start to skyrocket because we're concerned about the emergency. We got to get this back up and running as soon as we can. People are watching. That's when people cut corners. That's when they start to, let's deviate from the safety plan a little bit. And that's when we have accidents. When we plan things, we're always going to be much, much safer. And then energy inefficiency. So equipment is not running properly. It may actually take more energy to run that equipment. Electric bills go up, things of that nature. Here is a great picture of a piece of equipment. So this company, obviously a sawmill, they asked for a company to come in and do an evaluation so that they could be NFPA 70B compliant. And this is one of the things they find. This is a disconnect inside of a sawmill, and you see how filthy that is. All of that dust can absolutely combust and cause an explosion. A lot of times, things that are in there can also be conductive. For electricity, can cause an arc flash. You break down that ionization in the air, and electricity takes that unintended pathway, jumps from phase to phase, phase to ground. Now we have a plasma ball. Now we have an arc flash, an arc blast, all the things that go along with that. So Annex S, NFPA 70E, new for 2024, discusses how do we determine the condition of maintenance. This is something that goes hand in hand with NFPA 70B. Visual inspections, infrared thermography, electrical measurements, voltage and current, insulation and resistance, battery impedance testing, condition monitoring, ultrasound for partial discharge in corona. So a lot of things that we can do. So NFPA 70E is now incorporating that because they know that they're going to be working directly together to keep things safe.